All right. This will be the introduction to Perl for high performance research computing. If you go to our website, when you go to the training and the courses under Perl, you can go down and find the course materials here. We have the PDF, which will just get us started. We'll be using Jupyter Notebook. You can see all of the files that we'll be using on GitHub here. So there's the notebook, Jupyter Notebook, and then there's some example files that we'll be looking at. So let me go ahead and start with the okay, first of all, if you need, if you're working on our systems and you need any kind of help, you can always go to our website, look for information there. We have extensive documentation. You can always send email to help@hprc.tamu.edu. When you do send us a message, please specify what cluster you're working on, what's your net ID. If you're running any jobs, if you have some job IDs, and error messages that you get, if you can copy and paste them. And if you're using modules, what kind of modules you're using and so forth. So any information that we can use to try to recreate what the problem is and figure out who can best help you. So if you're working with any kind of Perl, a lot of times they'll send the question to me. I can help you with Perl programming. And then other people can help you with software setup and things like that. You can also give us a call or come by our help desks. We have the main help desk, which is in Henderson. And then we have an office here, which is open on Thursday and Friday. And then the Henderson one is Monday through Wednesday. And then this is just the website that I showed you to begin with. The first thing that I would like for you to do is open up the Grace portal. So you go ahead and log in. Okay. So once you've logged in through CAS, you can go ahead and just connect to the portal, which the website is portal-grace.hprc.tamu.edu. This will be the landing page. So has everybody been able to reach the portal?
Yes.
Okay. So once you've gotten here, the first thing that I want to do is to, if you can, we've added some features here, some of these buttons here, which are nice. So you can get to the Grace Shell access, which we'll be doing, and also to the Jupyter Notebook, which we'll be doing as well. So the first thing I would like for you to do is to log into your shell. So you go to the Grace Shell access here. And then you'll have to enter your password again. Okay, so now I'm logged into the system on Grace. And if I go to my Scratch directory, CD Scratch. So this should be Scratch user and then your net ID. And then what we want to do is we want to copy the GitHub. You see here. So we create a clone.
The text is not trying to type.
So this will be the command git clone, and then this address here.
text is not.
github.com/kjtamu/perl.git.
Keith, can you make the print larger, please?
I can't see it also.
Thank you. I think control, that, like you do on a website, I think works. What is it, control plus?
This is Greece. Try,
I don't usually use this browser.
that's where,
Did Control Plus do it? Or did that copy again?
Control plus.
Yeah, there you go.
Yeah, Control plus. So if you go to your, if you go to if you look at the slides, it has the instructions here, CD your $scratch, and then you can use git clone.
Can you show them how to navigate C file? real quick?
yeah, CD.
Sorry?
Can you show them how to navigate the slides again, real quick?
Oh, okay. To get to the slides, we start with the HPRC website,
Right?
and under training courses, if you scroll down to find the Perl class, and down here, it will have the slides here.
On GIT. Oh, HTTPS. Yeah.
See.
I did something. Oh, I copied it twice. Sorry about that. Git clone.
Did you type in git clone first?
So this just downloads a few files. Yes.
You said
What?
key.
Keys did you press to delete everything to the right?
Oh, okay. What I did is I just went to a certain point and I hit Control K.
Control K, alright.
Yeah, that's.
Thank you.
Yeah, that's, I've just been using Unix for a while, so
Yeah, cool.
I don't even think about which keys. So if you look, then it will create a directory called Perl, your scratch directory, and if you cd into Perl and you list, it should have those files that I showed you under GitHub. And then we need to go back to the portal, and we want to start Jupyter Notebook. Okay, I'll give you time to take a trip.
No, I don't.
After entering the Git below, is that the last step?
Oh, I think they all,
Before
you
you
also see this, type out as right here. You see all the things and you have Perl, so you go into change the attribute. And you can check the list too. So that's all things that you know.
Has everybody been able to get to this point?
Well, after.
All right, at Jupyter Notebook, we're just gonna open the standard Anaconda environment 5.3. We don't need to add anything extra. And I went ahead and set it to 3 hours, since the class is 2.5 hours. And we only need 1 core, and then 7 gigabytes of memory should be plenty. And we want it to be CPU only. If we select the GPUs, then that incurs extra charges. We don't need that for notebook. Yeah, and then these, I just leave these blank. This means it will go to your default project account. So as long as you have a current FY 25 basic, then you should have an account already. And we just click launch. Okay, and so once you click launch, then what you're gonna get is this dialog here. It'll let you know the you have a session ID and so forth. And then it shows that it's starting. So what it has to do is it has to start a job on the batch system, and it's going to be claiming one of the nodes or part of one of the nodes, and to get access to that. And then once it's able to start up the process on that node, then we'll get a connection to that. And so this will update. And at any point when you're done working on the notebook, you can go ahead and click delete, and that will stop the job, and it will stop any charges that you get for running the job. So this will just be, this will charge you 1 SU per hour, since it will be 1 CPU. And it's taking its time.
Oh, you want faster? Keith,
Yes.
will this work on faster as well?
Yes, it should work on faster.
Okay.
Some of the example, there's an interactive Perl program that I installed on Grace, which I don't know if that's available on faster. I don't recall. I don't think it is.
Okay.
We'll just have to switch over.
Yeah, it should work on either Grace or faster.
Back on the HPC.
So is this spell is it the same as terminal? Yeah. Terminal, this spell, this stack, is it the same as terminal? Is it accessible on terminal? L,
Is it accessible with?
terminal. Shell, or can we use,
What do you mean this?
can we use terminal on the system to access this L? Yeah, this field?
Oh, yeah. Are you able to log in here?
Yeah, is it the same as terminal? Is it the same as terminal on the PC? You know what I mean by terminal?
No, I don't.
Yeah, when you, the local is.
Like thing, you can also use like PowerShell on your Windows.
Like this Windows PowerShell,
Yeah, it should work.
we can access Perl from here.
Yes.
Okay, now I give, once I get to a point where it says it's running, I'll have it'll change to green up here. And it will show me the host that I can connect to. And then down here, I will be able to click this to connect to the Jupyter notebook. So has everybody been able to start their notebook job?
Yes.
It may take a little while to get connected. The system is kind of busy.
Just this one.
So once you get to this point where it says that it's running up here, you'll be able to connect by clicking on this button here at the bottom. And then this will open up a new tab. And this starts you off in your Scratch directory. So what you'll want to do at that point is just click on Perl to navigate into that directory. And then you can click on the notebook here. take a minute to do setup. Okay, so for this class, what I'm using is the Jupyter notebook. I don't know if many of you probably worked with this before, but this is based upon Python. But luckily enough, they made it, you can embed Perl into the Jupyter notebook, so we can run some Perl code in here. So while this is starting up, one of the things I want to show you is when you first start, you can do a restart and clear output, so that if there's anything that's saved from a previous run, it'll erase that, and so that you'll start fresh. So this is the agenda that we're going to try to cover today, and I'll be skipping some of this stuff on here that is not as necessary, so I can get to the good stuff with the language, because there's a lot of content in Perl, and in previous years I've taught this multiple sessions. So today we're going to just try to hit the highlights to get you started. Normally, if you're running Perl, you're going to be logged into a system like this. I'll be in a directory where I have some Perl files, and so I can just say Perl and then the name of the program, sum.pl, and it's just going to execute the content of that file. And if I look at, and this is just a very simple program here. It has one printf statement in it, and it has at the very first line of the program, it has a shebang, which is the hashtag exclamation, and then the path for the program that you're going to run. Now, if you're running complex systems where you need to import specialized Perl libraries, like with Bioinformatics and so forth, you may need to have a module load command, and so that will create an environment. And so the path to find your Perl program, you don't want to use the system default, because then it's not going to find the necessary libraries. So this is just if you're running more of the standard Perl with the basic installed libraries, which is quite a bit. But if you have specialized libraries, this is going to be something different, or you may just want to leave off that first line and then always execute your program by just typing Perl and then sum.pl. That shebang just says if I want to, I can run it like this, sum.pl. If I have the permissions set up right. So here I don't have execute permission set up. So if I say chmod on the file, I can make it executable. And then when I run it, then it's just going to run it using the path that I specify in that first line. But like I said, if you're using a specialized installation of Perl, you probably just want to stick with the standard call where you call Perl, which will be whatever path that the module system is set up for you. And if you're not sure about any of that, don't worry about that. If you run into a need for something like that, we can help you set up your path and so forth. So this just goes over what we already did. This shows what I just explained. Another thing I can do is if I'm in just a bash script and I want to just run Perl, because there's something that I can't do in bash, but I know I can do it in Perl. I can just embed a very simple statement like this. So if I run this in the shell, basically what I do is I just say -e, which says execute the following, and then I have to put it inside quotes so that the shell doesn't interpret it. So this is one way I can just run a very simple command in Perl. And I can do that here. In the Jupyter Notebook, each one of these each block that I click on, this is a cell. And if I click on one that has one of these at the beginning, this is an executable, so I can just click this to run the cell. So basically what this does here, %% bash says, okay, run the following as if you're in the bash shell. And we're gonna be doing that with the Perl. Run Perl, it'll have %% Perl. Another thing that I like to do is I'll type eval Perl. So the eval program in Linux, it will just run this command here. And then it will, whatever I type in is going to be my input, and then it will just feed that to that program. And unfortunately, unlike programs like Python, Perl does not have a default interactive version. But what I can do is I can just take, if I'm writing on a big program and I want to work with an array, and I said, okay, I want to print this array out. Well, what's the syntax that I want to use? Here I have 3 different examples. If I'm able to just type them in interactively, I can immediately get results back, and that lets me know what if my objective is to print them out with the actual items with spaces in between, then this is the syntax that I want to use in my program. So that's one way that I've used to just to test out some programs in Perl. Another program, which I don't think it's installed on Grace, but it was installed on Terra, which is now retired, was Perl Console, but that's kind of outdated. There's a couple programs that I have installed, Scratch Training Perl, capital P Perl. So if I look at that, and let me make sure it's there. Yeah, so there's a program I have there. If I run this, Scratch Training Perl, then Perl I, this lets me run Perl interactively. It's going to take a minute to set up. And well, that's running. Okay, so this one, you can download this program from GitHub and you can install it on whatever system you're going to be running on. It requires, that one does not require any other modules, I don't think. But this other one here, this is a very basic thing. If you have the program called RL Wrap, which I installed as a module on Grace, then you can use that one. Now, it's not starting. These may be outdated, so I'll go ahead and skip this for now. So I'm not sure if the modules have been retired or something. So sorry about that. Okay, in order to look at the documentation for Perl in Linux, what I can do is I can type man Perl. And this is basically, it gives you a table of contents. And so there's all of these different man pages that I can also refer to. So if I wanted to get a short introduction to Perl references, I can go to this one here. So I say man Perl ref tutorial. And so then this gives me a long man page that I can go through. That's the old system. If you go to perldoc.perl.org, this has all of those man pages in a nice HTML format. So I can look up like that tutorial. I can look up the reference tutorial, go through this, and if this takes you through step by step how to use references and things like that. We'll briefly touch on those today. A lot of the, you can have information on operators, on the many different functions that are built into Perl, some standard system variables, modules that you can load, and a number of other. The tutorial are the ones that I learned the most from. If you want to start learning about doing regular expressions, going through their tutorials gives you a lot of good examples that I won't have time to go through today in the class, but I'll give you a few examples. But if you want more extensive ones, then these will give you quite a lot more details. Okay, so let's start looking at a Perl program. Perl statements are separated by semicolons. And if you have a statement block, it's going to be surrounded by curly braces, which is in quite a number of other languages. The comments are with hashtag symbols, the pound sign. So anything after the pound sign, as long as it's not inside of a quote, that will be considered a comment. And I highly recommend you add lots of comments as you're writing code, so that when you come back to look at it 3 months later, you have a better idea of what you were trying to do. Or if you're letting somebody else run your program, then it helps them to understand. So this program here, it just creates a little loop. It goes through and it prints out some numbers in a table. And I'm using the printf, which is taken from the language C, also use C++ and many other languages. One of the things here, if you'll notice, Perl has an exponent operator, which is 2 asterisks, which is kind of nice. All right, so if we look at the variables here, notice that each variable, you have to put a symbol in front of it. In almost every case, that's going to be different when you're working with file IO. But for regular variables where you're storing numbers or strings or arrays, you're going to have a symbol in front of the variable name. And in Perl, a dollar symbol means that's a scalar. It's going to have one single value, numeric, either integer, float, or a string, or it could be binary data, or some kind of pointer. And here I have an array that I'm working with, A sub I, and notice that I have a dollar in front of the array number, array name, and also $sign in front of the I, the index variable. So this can get a little tricky. You get a lot of the symbols you have to keep track of, and we'll go over how these are going to be used with arrays, hash tables, and things like that. The names in Perl, they have to start with the letter. You're limited to letters, numbers, and underscores, and it is case sensitive. So if you accidentally hit the shift key in the middle of a name, Perl is going to treat it as if it's a separate, different variable. So be careful with that. So the major types of variables in Perl are the scalars, which is the $sign. You have lists, and I'll use the term array. Technically in Perl, it's a list, but to me, an array is the same thing. And then a hash table is basically a specialized array that has a key and value combination. So working with scalars, we can have integers, floating points, string, binary data, reference. Perl is not strongly typed, so if I assign, I can't say that this variable has to be a number or this has to be a string. So if I try to assign something if I try to assign a string to something that later I consider to be a number, Perl's just gonna be like, okay, and it will just convert it without complaining. So you have to be careful with that. You have to keep track of your variable types. Make sure you're you're not putting something in the variable that is the wrong type. And notice I have here these strings where I can have a single quote around them, or I have a double quote around them. That there's slightly different meaning to those, which we'll go through. But that's just another different type. And so if you go ahead and run this one here, what I've done is I've assigned a number to the variable A, and I assigned a string to the number or to the variable color. And then when I have these print statements here, and inside the print statements, I'm just printing the variables within the string. And I can only do that because it's the double quotes here, but we'll go over strings in a little bit. Okay, so that's very basic. With lists, if you're referring to the entire list itself, you have to refer to it with an @ symbol. And then then you can refer to the entire list or a sublist. If you're referring to just one single value within the list, if you're just grabbing one value, then you're going to use the $ because that's just one item inside of a list is a scalar. In Perl, all of the lists are one-dimensional. So if you want to do a two-dimensional array, basically what you need to do is you make a list of pointers to other lists, which we'll go through later.
So what is the main function of the $sign in Perl?
I'm sorry?
What's the main function of the $sign and %%?
Oh, of the ampersand?
$sign?
Oh, the
Yeah.
$sign? $sign indicates that the following is a variable which is a scalar, which is one single value. So if I refer to one item within the array, that's why I put the $sign in front of it. Even though if I want to refer to the full array, I refer to it with @ symbol. So I say @ symbol A, and that refers to the whole list. And if I refer to the index 5, then I just say $sign A in bracket 5. And so that is the rules for Perl up through version 5. There is newer versions of Perl, which are kind of experimental, and they've been in the works for many years. They haven't become standard. And as I understand it, newer versions of Perl are going to change that rule so that this will be different. But for now, all of the modern or all of the current versions of Perl that are in production, unless you're working with a newer version of Perl, it's going to be following these rules. So there is a slight change. It's kind of like going from Python 2 to Python 3. There is a big change going from Perl 5 to Perl 6, but I have yet to see anybody using Perl 6 in production.
So what about the double %? %%? What is that? Double %.
Double %? Oh, I'm sorry. This right here, this just says that this is a symbol that means when we're working in the Jupyter notebook, that says that the following code, everything within this cell is a Perl to be interpreted by Perl. Because normally if I take this off, if I delete this, then it will treat it as Python. So if I do this and I try to run it, it should give me lots of errors. Yeah, it's not going to like that because that's not Python. But if I say this is Perl, yeah, this is not, you're not going to see this inside of a Perl program. If I open up one of these Perl programs here. So if I look at this one, I'm not going to have that in there. That's just a specific code in the Jupyter notebook to indicate that I'm running Perl. So,
So in the same way, when you say percent bash earlier,
yes, yeah, then it would treat it as a bash shell. So if I try to do this, then it would, yeah, this would probably give me lots of errors. If I did bash. Yeah, it doesn't like that syntax. So that just means that I'm running Perl. And I run it.
and over there it was bash shell, the Perl program. Is it,
Yes.
was it the bash shell?
Oh, back here?
Yes. Is this the bash shell you're using?
Yeah, this is bash that I'm running in here, but if I wanna run a program, then I just run it with, I specify this program is gonna be run with the Perl interpreter.
Okay.
Yeah. Okay, so with the list, I can specify, I can assign a full list, and I put it inside parentheses, separated by commas. These can be numbers, strings, I can do a mixture of multiple types of data within the same list. And then Perl, what happens here in Perl, you have index 0 is gonna be the number 2, index 1 will be 3, index 2, 3, and 4. So when I say A of 5 is equal to 13, what that does is that will expand the list. And so Perl will automatically handle all the memory. So if I tried to do this in C, if I initialized an array, then I tried to add to the end of it, it would say, you know, it would give me a segmentation fault or something saying that I'm out of bounds. But in Perl, it doesn't care, it keeps expanding it, and it will grow the list. If I want to know how long the list is, what I can do is I can assign the list to a scalar. So if I cast the full list to a scalar, then the way that Perl interprets that is, oh, you want to know the number of items within the list. So in this case here, I have 1, 2, 3, 4, 5, 6 items in the list. And then they have index 0, 1, 2, 3, 4, and then 5. And if I want to know what is the highest index in a list, which is good if I want to create a for loop to go through every item in the array. The syntax here is I just say $, $, and then the name of the list. And that gives me the highest index for that list. Okay, so the length is always going to be 1 more than the last index. Now, what if I change this, go ahead and change this to a larger number, say 15. I don't have. Okay, so let's say I do this. So this only goes 0, 1, 2, 3, 4. So 15, it's gonna skip a whole bunch. So what do you think is gonna happen in that case? Yeah, it'll put it on the end, and then there'll be a whole bunch of undefined values. There'll be basically like a null value. And then when I go to print it out, here where I print out my list, it just prints it as just nothing. So it'll just put a space in between, and then there'll be a 0 width item for each of these things that I put. So if I do it to 25, it should push it out even further to the right. But then if I tried to work with any of those that are in there, I could get an error that it's an undefined value. Or even worse, Perl will interpret it as, it'll just say, oh, okay, you want a number for this, I'll just give you a 0. Which that could be a problem if you're expecting a real number there. And I'll give you some hints on how to avoid that kind of problem. The next thing is an associative array, which is a hash table. And instead of using the ampersand symbol, you're going to use the % symbol, one single percent sign. And then that indicates that we're gonna have a list of special properties where you're gonna have pairs. You have a key, and then this points to a value. The key and the value are both gonna be scalar. So if you wanted to have a hash table that pointed to lists, you'd have to use references, which we'll get to soon. But for the regular hash table, when I first initialize it, when I specify key value pairs, what I do is I have the key, and then I have this construction here, which is like an arrow, the equal, greater than. So then I have key pointing to value, comma, another key pointing to another value, and so forth. So if I initialize a hash table in this way inside the parentheses, I always have to do that in pairs. So if I had tried to do something like that that doesn't have a value, let me see what that does. Okay, so it creates it, but it's basically just a null value. I expected it to print out an error, but that's one thing about Perl is it will do things, and even if you make a mistake, it'll keep running a lot of times, so you have to be careful. And now if I want to refer to something within the associative array, instead of having the square brace, I use the curly brace. And again, since I'm going to a single value, it's going to be a $sign instead of the percent sign. So percent sign refer to the entire hash table, and then the $sign refer to one specific item within the hash table. And I can add new items just by doing the assignment like this. And if I wanted to, I can say, I can overwrite an existing one. So go ahead and which one you want to pick? Phone? Go ahead and try doing this where you overwrite it. And you can do something like that. Then I want to print out. See if I can print out the entire hash table. Oh, I forgot my semicolon. So here I went ahead and I overwrite. Oh, it doesn't like me. Try. Okay, so that it will just dump it out without any kind of formatting here. I would expect it to put. Oh yeah, it's not interpreting that, so that's kind of strange. Yeah, so normally what I would do if I want to print out a hash table is I would make a loop to go through. So I could say something like for keys print like that. And so this should print out, okay. Oh, I didn't put a new line here. Okay, so this normally, like if you're gonna process a hash table, you want to go through every key within the hash table. And here I assigned, I call this function keys. You give it the hash table and it will just give you a list of all of the keys that are in the hash table. Now notice that I have name and phone that I assigned first, and then I assigned age, and I overrode phone. But it basically the order of the keys is not predictable. It's pseudo-random. So if you want to print out the keys in a specific order, you have to either do a sort or some other way to arrange them in the order that you want them to be. All right. Now, one very strange part about Perl, which I don't like, is that you can use the same variable name for different types. So $X could be a scalar, then $X would be a list, %X would be a hash table, and then the $X, which we haven't gotten to that, but if you define a function, I can define a function by the name X. All of these are going to point to different places in the memory in Perl. And if I make it capital X, that's since it's case sensitive, that'll be another one. So you'll have the same variable name, and it will refer to different variables. So if you're not careful, and I'm working with a list, and I want to refer to one specific item in the list, and I forget to do the square brackets, I could accidentally be referencing a separate variable. So my advice is to never reuse the same name if you're going to be working in different types, because that's going to be just confusing. And if you turn on strict, which we'll do in a little bit, basically, if you haven't declared a variable, then and if you accidentally use it, you put the wrong symbol in front of it, and so you're trying to refer to something else, then Perl will give you a warning for that. But normally, it just Perl out of the box, you can do all of these, and it's not going to complain. You can shoot yourself in the foot doing that kind of thing. So my advice is always to use different names. So this just illustrates here one example where you have a list and then a scalar by the same name. And here you refer to the scalar, and here you refer to the one item within the list. And it can be confusing if you're trying to read that. You could mix up the two. So if you just use different names, then you can avoid that. Okay, when I do an assignment, I just have some value or some expression on the right-hand side, and I use the equal sign, and then on the left-hand side, I have to have something that refers to a memory location. So that's going to normally be just the name of variable. And in Perl, sometimes you'll get an error message that'll say illegal L value. What that means is you're using something in a context where it's expecting to have a memory place to put the data, and you haven't adequately expressed that. So that's where it gets L value from. It just means the left-hand side of an assignment. But if you're calling a function where it expects one of the function arguments to be a variable, then it will give you that L value warning. That's where that comes from. Another thing I can do is this is borrowed from C, is I can say plus equals times equals. And so that's just the same thing as saying this is equal to this plus 10, or this is equal to this times 2.5. There's also the string concatenation, which is the dot symbol. And I can also do the bitwise arithmetic as well. When I'm referring to numbers in Perl, if it's a number starting from 1 to 9, it treats it as a decimal integer, unless I have a period in there. But if it starts with a 0, it expects it to be an octal. So be careful if you try to if I said Perl X is equal to, or S is equal to 0.9. Print. Okay, and it'll say illegal octal digit because it started with a 0, so it expects it's only going to be 0 through 7. So that's one little caveat. And you can also do hexadecimal, floating point. You can do the scientific notation. When I'm working with strings, if I put single quotes around something, then this is the most protected. In other words, everything that's inside there, it's going to try to interpret it literally as just what's in between the two single quote symbols. If I have double quotes, then what I can do is I can have like a \T for tab, \N for a new line, or I can actually put variable names as you've seen in some of the examples before. And then there's also the here document where you have the less than, and then you have a special symbol that marks where the end of your string is going to be. And this is good if you needed to print out several lines and you want to embed some of your variables in there and you want to line them up with tabs and so forth, you can use these. There are some, if you go to this documentation on quote unquote like operators, it will give you more of the details on how to use here documents and so forth, which I find very useful in certain contexts. So if you're wanting to use that kind of feature, I would go ahead and read this because there's a lot of syntax rules for those. They're kind of strange because you put the semicolon up here before the actual quote itself. All right. So with the difference between the single quote and the double quote is shown here. So if you go ahead and run this, then you're going to say, you're going to print out what these are here. And this string, I've assigned it using double quotes, so it does interpolation here. So it replaces $name with this variable here. And here I use single quotes, so it just stores literally just the dollar symbol, NAME, and then that's it. And so when you go to print it out, that's what you get. So that's the difference between the double quote and the single quote. And then here's an example with a here document. I start off with the up here, I say I'm going to print everything up to this line here that starts with this. And since I'm using double quotes, it's going to interpolate all of these variables and also the \T that makes the tabs. So go ahead and change this here to be single quote. And then run it and then see how it runs different. So when I do the single quotes around the special end symbol, what that does is it says, okay, everything up until I reach this here, I just want to print it out exactly as is. So it prints out the dollar and the variable name without actually changing it. And it'll, instead of giving me a tab, it'll have the actual / symbol and a T. So that's just an illustration of the difference between the two. The numeric operators in Perl are mainly borrowed from the standard languages like C, C++, Java. Plus we get the exponent. Now we do have some extra operators. This is supposed to be formatted. Okay. sorry about that. So you have the dot symbol, which means to concatenate two strings, and then the X operator, which means to repeat a string multiple times. Then you have regular expression operators with the tilde symbol, and then you have some substitute, transliteration, and some other things. If you want, you can go to Perl op. This will go through and explain a lot of the different operators. And one of the things that I find useful is this will give you, this table here gives you the order in which it does precedence. So like, for example, it will do exponents before it will do multiplication, division, modulo, and then it will do those before it does addition and subtraction. So it's the PEMDAS rules. But then there's a lot of different other operators that you can look at as well. And okay, so a few of the other items that you can get, okay, like I talked about before, they have the exponent, and then the plus plus and minus minus. Plus plus works if you have it after the variable, it gives you the value of the variable before you do the increment, or if you put it before the variable, it will give you, it will do the increment and then give you the result after. Same thing with the minus minus. Percent sign is to do modulo arithmetic. If I'm comparing two values, I can either compare them numerically or I can compare them string wise. So if I look at a list of numbers, if I sort them in the dictionary order, then it'll be like 1 and then 10 and then 100, and then it'll start 2 and so forth. But if I want to sort them numerically, then I'm going to do comparisons by number. So if I'm comparing two items, I have two different ways to do the comparisons. If I'm comparing them numerically, I'm going to use the mathematical symbols. These are the same as in C and C++. So you'll have double equals to say this is equal to this, greater than or equal to, greater than, less than or equal, and so forth. And then to say not equal to, it's the exclamation equal. And then if I want to compare things as strings, then you're going to use English or Roman letters. So it'll be like EQ for equal, LT for less than, NE for not equal, and so forth. If I want to do a sort on a list, one of the things that I can do is I can give it a function on how to do the sort. And one way to do this is there's a special operator in Perl that does a comparison, and it has a left-hand side and a right-hand side. If they're the same, then the result of this operator is going to be the number 0. If the left is less than the right, then it's going to be a -1. Otherwise, it's going to be greater than number 1. The same thing if I'm doing it, comparing things as strings, I'm instead of using less than, equal to, greater than, I'm going to use the letters C and P. And so then it will compare them as if it was sorting it in a dictionary. Okay. For logical operators, there's two different ways to do logical comparisons. If I want to say this and that, or this or that, and I can use the operators as I would in C or C++, which is double ampersand means and, double vertical bar means or, exclamation means not. Or I can use the English word A&D, NOT, and OR. Okay, so these are two different ways, and if you go back to this table here, you'll see that it has okay, here's the double ampersand, the double exclamation, or I'm sorry, double vertical bar, and then way up here is the not, And then you have a number of operators that are in between those. And then you have some operators which are beneath them. So it can be a little bit confusing. So what I would like to do is if I use the symbols, I would always put parentheses around parts of the expression to make sure that they're evaluated in the right order. Or what you can do is you can use the English words, and these are always evaluated at the lowest priority, at the lowest precedence. Okay, so that way you could leave off the parentheses. I prefer to leave on parentheses just so it's easier to read. But just in case you're writing something with a complex expression and it's not working the way that you expect, you may check the order of precedence in that manual. There's also an operator borrowed from C where you have a condition. I'm going to test, say, is this variable here not equal to 0? Well, if it's not equal to 0, then the result is going to be this part here. Otherwise, if it's equal to 0, then I'm going to give it this. So in this case here, I'm going to try to divide one number by another. But if the denominator is 0, I'm just going to return back something to indicate that it's division by 0. All right, and then like I said before, you have the string concatenation, which is you have one string dot, and then that will just glue those two together. The repetition, where if I want to repeat a string 10 times, then it'll just say AB, AB, AB 10 times. There's also a range operator, and this will give me a list that starts with the first number all the way up to the last number. And these are going to only be with integers. Okay, so here's one example where I can take two strings and I either want to order them as first name and last name or last name comma first name. And so what I do is, in order to put them together as first name space then last name, then these would be the operators that I use. First dot, and then I have a separator character and a dot. So that glues those two together. What would be another way to put the two together with the space without having to use that operator? We've seen that before. So I could say, quote, first space last. So then I don't even have to worry about using the concatenation because I use the double quotes, so it does interpolation. Okay, so what this does is this will just take the first name. It'll print the two different formats, either last comma first or the full name. This will do the repetition operator, and so you can change this number to be a different number if you want to. And run these. Add that in there. So you can see the comparison. So so this is the same as this. I get the same full and other are going to be the same string. It's just two different ways to do the same thing. And then when I print out howdy, I can print it out as many times as I want. And I added a space in there just to make it a little more readable. And then I made a list from 1 to 55 and printed that out. So this just illustrates some of these operators that are useful. So let's start looking at the language itself. We're going to have a number of control statements. We have is, if, else if, else, and we have an unless, which is the opposite of else, of if. Then these, which I'm not going to cover, these are newer additions to the language, which are kind of experimental, and you have to put special things in there. And then there's several different ways to do loops. You have a C style loop for, then you have the 3 clauses in there. Then you have for each, which is borrowed from C shell. And then you have a while loop or an until loop. So with the if statement, you just make a test, and if that's false, you drop down to the next one. Else if, in Perl, it has a strange combination where they leave off the E and the else if. So that's just the nature of the language. One thing that I need to specify about Perl is, even though I only have one statement here after the if I was writing this in C, I could leave off these curly braces. But Perl is very pedantic. Any type of statement like this with an if or a loop, you always have to have the curly braces that control the statement block. It doesn't allow you to have a bare statement, one statement by itself. So even if you have one statement, it has to be surrounded by the curly braces. So here I have the if, and if it drops down, if this is false, it goes to the next one. If this is false, it keeps going until it gets down to the final else. Okay, so we can run this, and you can work with that, but yeah, we're kind of short on time, so I'm going to keep going forward. This is one straightforward way to implement this, where I'm going to choose the letter for the grade. Here's another way, which is a little bit shorter, and this illustrates the difference between if and unless. Unless is just the opposite of if. So unless the grade is greater than or equal to 70, it's going to be an F. Otherwise, and then here I just cram everything together in this. I use these tertiary tests where I have, if it's greater than or equal to this, it'll be this. Otherwise, I go over to here. And this one, I have to differentiate between a B or a C. So this is kind of like putting all the same logic here into a shorter form. And one of the things people say about Perl is there's always, 10 different ways to do the same thing. Here's a new one where you use given and when, which is kind of like switch and case. But normally you have to use these special directives up there, otherwise it gives you a warning. But I'm not going to cover that because it's not commonly used. But if you want to, you can look into that. Another thing you can do in Perl, which can be useful but can also be really difficult if you're reading somebody else's code, or somebody else is reading your code, is I can say do this statement here, but only if this is true, which is kind of a shortcut. So instead of saying if this is true, then do this, you put it after the statement. Now, if I put it on the same line, I find it to be confusing because I just see a print statement and I expect, oh, this is being printed. Unless I scan all the way to the end of the line and I see the if statement. So one of the things that I do, if I do something like this, is I'll put it on the next line, and do an indent like that. That makes it a little more readable. But that's kind of, if you want to do something quick and dirty, you don't want to put all the curly braces in there. But I tend to avoid that if it's something that is going to be used a lot, or if somebody else is going to be working with it, because it tends to be confusing. The same kind of thing can happen where I can use the operators. I can say, if this is true, then do this. Well, in Perl, they have what's called lazy logical evaluation. So if I have an and operator, then what happens is it will say, if A and B, if A is false, then it's not going to evaluate B. Or if I say A or B, if A is true, then it won't evaluate B. So in order to take advantage of that, what I can do is I can put some kind of test and say, okay, only if this is true, then go ahead and do this. Then I just put the and operator. So in that case, if this is false, then it will just skip it and not do it. So it's kind of like doing an if statement here. The same thing with the or. Again, this is, if you're writing code, it can be a quick and easy way to do it, but it can be confusing. So you may want to be more explicit and just use the basic if or else symbol commands. Okay, while loop is just like in most other languages. While some condition is true, do whatever's in the body of the loop. And so this one here, I just have a loop. I start I at 0 every time through. I add 2 to it. I'm going to print I and I times 23 until as long as I is less than 7. So that's a very simple loop construction. The for loop that you used from C or C++, the format for this is you say for, and then it has 3 clauses. The first clause is to initialize. So I assign something to the variable. And then the second clause is the test. So as long as that test is true, it will keep going within the loop. And then the final one is the increment, which happens at the end of the loop. And as long as the loop, that body of the loop finishes, then it will call this last one to do the increment. So this statement here is the same thing as this while loop here. It just puts it into a nice compact format. And so we can run this, and you can work with this, change this to be what you want. And then it just runs through the loop with each of these clauses being evaluated as if it was a while loop like this. There's also for each, which I did before, where I say for each, and then I have a loop variable, and then inside the parentheses I have some list. And the list can either be something that I put in there explicitly, like, I could put in for each, I think I did that. No, I did that on a different one, I'm sorry. But with the for each loop, basically what it does is every item within this list gets assigned to this loop variable, and then it runs the body of the loop. Okay. So here I would have a list that I set up, and then each time through it, I'm just printing out what it is. If I have a list that I've already assigned values to, and I want to go through each item within the list, or in this case here, I'm actually initializing a loop, or initializing 2 arrays. But what I can do is I can say, go through each index from 0 up to 20, and for each one of those, do this operation on this array. Yeah, I didn't. Okay, this is not an example of what I have here. So this is a more common construction here, where I say for each index, and then I go 0 through the highest index for that array. So this assumes that I have this array here that I already initialized, and that I have a number of values in it. And so what I need to do is, for every item within that array, I'm going to print out what the value is in this nice format here. And I think I actually took out the example that I had here. But this is an example where I'm actually setting up a new variable, or 2 new variables here, and I go from 0 to 20. And so this just prints out the squares and the cubes. for those numbers. All right, I can also use the for each loop on the hash table. So let's say I created a hash table and I stored some key value pairs in there, and I want to go through and for every single item or every single pair within this associative array, I want to do some operation. So I can iterate over the keys, which I call the function keys on the hash table. And then, so this will first give me, well, not necessarily in this order, but it will give me each of these keys. And then I can look at what the value is and then do some operation here. Okay, and here's another example where if I want to go through a hash table, but let's say instead of just looking at the key, just iterating over the keys, what I want to do is I want to look at the pair. So I use the operator or a function called each. So I use this while loop and I say while, and then on the left-hand side, what I've done is I have a list of two variables because each returns back a pair of two variables. And so each time through, every time I execute one of the iterations of the while loop here, each is going to return the next key value pair from that hash table. And so those will be stored in the $K and $V. And so each time through, this is basically the same thing as that I did here, but I've already got them stored into the variables K and V. So this runs the same thing as I did here. Another thing that I can do, instead of actually writing my own loop, is I can call a function called map. And what map does is it says for every single item or every single element of whatever list that I give to it as an argument, I'm going to do some operation. So here, what I do is I have a little bit of code. So this is basically what Perl considers this is like an anonymous function. What I could do is I could say map and then give it a function name and then the list. And so every item in the list is going to be fed to that function, or in this case here, this block of code. So all this does is it tests if the number here is greater than 150. If it is, then it's going to print out that thing. So it's the same. So these are three different ways to do the same, to iterate through your hash table. Map is a very powerful function. I would recommend looking into that if you're going to do a lot of list processing, because it could be a big time saver rather than having to construct the loops. The map function basically just does a lot of the overhead for you. So let's look at some of the more common syntax errors that you're going to encounter. So just so that we can avoid, so we can learn how to avoid some of the common mistakes. So here I'm going to say, give me a random number, and I'm going to make a test to see if this is greater than 0.5. So I'm going to get a random number between 0 and 1. And then if it's greater than 0.5, I'm going to print this out. So from what you know so far, what would be the error that it's going to complain about here?
Curly brace.
Yeah, because I don't have the curly brace. So it'll say syntax error, the percent, or the right brace print. It's going to say, I don't know what to do with this because I'm expecting something else. So if I come in here, add my curly braces, and I rerun it, oh, see, Jupyter Notebook is not, it tries to be nice and gives me a matching curly brace. Okay, so then I'm able to do that. And since it's random, Yeah, okay. So each time you run it, you're gonna get random results. Okay, now here's another one. What would be the error involved with this? I initialize an array, I wanna make an assignment, and then I wanna print out the values in the array.
Dollar sign.
Right. So I don't have the dollar sign, and Perl doesn't like if you have a bare word. If this is not, it's gets confused because it probably expects that's a function call. So by doing that, then you fix that. Now, again, these are length values because I set it at a much higher index. Okay, here I have 0, 1, 2, 3, 4, 5, 6, 7. Okay, so what I'm doing here is I'm gonna go through the loop, every item, every index within the loop, from 0 up to the highest index, and I'm doing some testing here. So I wanna test to see if the value is equal to 7. If it is, then I wanna print it out. But if I run it, notice that every time it says the value is 7. That's because I use a single equal sign, which means do an assignment instead of doing the test. Well, if I turn on warnings by putting use warnings up at the top, then it will say, hey, I found a single equal sign on line 9. So I go down here and say, oh, okay, I fixed that, and I run it again, and then it works as I wanted it to. Okay. So having use warnings on is, I highly recommend that because it will give you some heads up whenever it encounters something that is unusual that you may need to fix. Now, warning will not stop the program. It'll just print out a message that say, warning, look at line 9. Which is different than error. With an error, if it's trying to parse the program, it will get to a point and it'll say, oh, this is a syntax error, and then it'll stop at that point. So that's the difference between an error and a warning. The error can happen at compile time. So if you have some syntax error, or it can happen at runtime. You try to divide by 0, or you have some kind of reference or object error. Okay, so another way I can do that, if we look at balance.pl, here I have two items within there, and I'm trying to add up 3. Okay, so this last one, I would like for it to give me a heads up to say I haven't assigned anything to this one. But without warnings turned on, then if I say Perl balance.pl, then it'll just run it as is. But if I put either if I put use warnings at the top of the program, or if I just put the -w, then it will say, oh, hey, line 7, you have an uninitialized value that you're trying to add to. So if I look at that line 7 and say, oh, okay, I forgot. No. And I can try to fix the logic of my code so that I'm not using an uninitialized value. So I always recommend putting on use warnings or the -w. Okay. Then we saw this before with the double equal sign. With syntax error, okay, we'll skip that one. This one here, the close EQ. Okay. here I have a quote that I start here, and I don't put a close quote. So if I say Perl close u.pl, then it'll give me all these errors. And what you need to do is you need to say, okay, you have a line 8 is where it actually finds it, which is way down within the program. But then you look at this next line, it says, oh, it might be a runaway multi-line string starting at line 3. So whenever you look at those error messages, try to scan down and see, okay, it says the error is down here on line 8, but if you go back to line 3, that's probably where it started. So that's for runaway strings, this is the format that you're gonna get. So that's one way to look at it. Another thing that you can do in your programs is you can add some diagnostics so that if you run into a condition where you know, okay, the program there's some kind of failure, I didn't get what I expected, so I'm gonna go ahead and quit, and I'm gonna print out some diagnostics. So there's a function called die, and you just give it a string, and you say, okay, at this point I was expecting a denominator that was greater than 0 or not equal to 0, but I have one that's equal to 0, so I'm gonna quit the program. And if I don't put a new line at the end of the string, what die will do is it will give me a line number. It will say on line 23, denominator 0, and I can put whatever I want within these string, so I can put like the values of variables or things like that to give my own diagnostics. Or like, let's say I'm working with a file, I need to make sure the file exists before I try to open it. If it does not exist, then I can just say, hey, I'm trying to open this file here, but it doesn't exist. So I just go ahead and quit the program at that point. So that's the die function works very well for being able to do self-diagnosis on problems within your program. There's also a function called warn, which does the same thing, except for it doesn't quit. It'll just print out a warning line, and then it will keep going. And then there's also a library card where you can get like the stack trace and things like that if you need to get a deeper analysis on some kind of error that you have. One nice thing is you can add a $! So let's say I called the open function and that failed. So for whatever reason, I tried to open a file for reading and this failed. And so when I call die, would I say, okay, I tried to open this file and I give it the name of the file, and then I print out $! And what that is, that's the system error string. It'll say, file doesn't exist or permission denied or something like that. So whatever reason that the open call failed, and that will print it out. So okay, so I'm trying to open up need file. If that doesn't exist, it's going to print out this error message. So Perl, no file, no such file or directory. Okay, it wants this file here. So let's say touch is a command that just creates the file, an empty file. So it's just an empty file and I have permission to read it. So when I call that, it's able to open it up without any problem. But let's say if I did chmod. Okay, so then when I list it out, I don't have any permissions for that file. And when I run no file, it'll say permission denied. So instead of saying no such file, now it says permission denied. Okay, so let me remove it and then say make directory a file. I'm curious what it will do with this. Oh, it actually opened it up, so it didn't have a problem with opening a directory. But okay. Now, before I mentioned one thing about if you want to keep track of your variables, you can declare them ahead of time. And then if they're not declared, you can get an error message if you try to use something that's not declared. The way that you declare local variables in Perl is to use the my directive. So you just say my and the name of the variable name. And I can list multiple variable names, but if I need to say declare multiple ones, I have to put them in parentheses. And I can also initialize a value when I use the my command or my directive. So I can say my $x is equal to some value. And I can also embed it inside of the code. So let's say I wanted to use this variable only within the body of the loop, then I would, the first time I use it, I would put the my directive in front of it. And then it becomes a local variable within that loop. It's declared. And as soon as the loop ends, then it goes out of scope. So here's an example where I have a variable item and I declare it just for this loop here. And when I run it, what happens is it's gonna print out every item within this array. And then when I get after the loop, I'm gonna print out what item is. And so what do you expect it to be? So this should be outside of the scope of the loop. So this should be separate. So, and in terms of the language, this is going to be a separate variable than this. So this one has not been declared before. I haven't assigned anything to it. So let's see what I call it. Okay, so the last one, it just prints out an empty string. It's an undefined value. And then if I did, okay, so this one, if I turn on strict, it's going to say, oh, okay, you have this variable on line 10 that wasn't declared. And if I look at the code, all right, I tried to use it here. I say, well, I declared it here, but that means it's only local to this loop here. Okay, so that's just a matter of scope. And what I could do is I could say my item equals O. If I do that, I've declared it, so it shouldn't complain. And even though there's a local variable or there's a variable only within the scope of the loop that's given the value 3, 4, and 5 here, this item variable and this one outside of the loop, they're two separate ones. So since I'm reusing the name, of course, I break my rule of don't reuse names. So, and that would be very confusing to read that, but that just gives you an illustration of how the scope works. So we use strict to turn on, make it enforce it. I have to declare a variable. And if I have not declared the variable X before I use it, it's going to complain. So then I have to fix that by actually declaring it, which is nice. Now, I like to use the strict directive because if I've declared a variable and then later on I have it down in my code, I mistype it, I transliterate two letters or something like that, it'll give me a warning, say, hey, you didn't declare this variable, and I say, oh, I misspelled it. So that saves me the problems, because if I don't have strict turned on, then if I misspelled it, it's just gonna give me an empty or a zero, whatever. And I'm gonna be pulling my hair out, not knowing why I'm getting that result. So I always turn on use strict and use warnings. All right, now let's start looking at file IO. In Perl, when you first start a program, you're gonna have standard in, standard out, and standard error, which is the same as in C or C++, but by convention, the old style Perl, the file handles, when you created a file handle, you didn't have to put a $sign in front of it, but to indicate that it was different than, you know, a regular scalar variable, the convention was to put it in all caps. And that's not strictly, or I mean, that's not enforced by the language or anything, that was just the convention. So that's how you get standard in, standard out, standard error in all caps. I can also assign a file handle to a scalar variable, which is more consistent with the newer versions of Perl. So that you're kind of seeing some of the old, as Perl developed, you know, it added some more rules to it and so forth, and so these were kind of left over from the old. But you can also, what I like to do is there's an IO file. Under modules. Okay, IO file. Yeah. So if you look at this manual, this will give you a lot of examples on how to do it. And this allows you to do file IO using object-oriented methods, which I find to be a lot more useful in most cases. But I'll go over the basics of working with IO. There's two different modes. There's the regular buffered IO, where you have your whatever you type in or you read in from a file, and then whatever you print out to the screen, which is just going to be normally just ASCII based, or whatever your character set is, and then it's going to be buffered. You're going to be able to put, go line by line in most cases. And then you have the unbuffered. Let's say you're working with binary data, and you're going to read it in terms of the number of bytes, or you're going to write it in terms of the number of bytes and so forth. And this gets confusing. Okay, sorry about that. Okay, so print and printf, those are using the regular buffered output. Print, you give it a list of strings and it prints it out. Printf has you have the format string, and then you have the arguments for that. System write, that's unbuffered, that's for binary data. And then if you are printing to a file, what you would do is you would say print, and then you give the file handle, and then your arguments. And you don't put a comma between the file handle and the arguments, either with print or printf. That can be kind of confusing, and it's easy to forget. But that's just kind of borrowing from the old style Perl. When you use the when you use the unbuffered, that does take arguments which do have commas in there. Okay. And one thing is, when you're using a buffered or unbuffered, you can't mix the two. So if you open up a file, it has to be opened up in binary mode. and unbuffered, and then you can use sysread and syswrite. But if you just open it as a regular file, then that's gonna be buffered and you can't use syswrite or sysread with that. Okay, so most of the time you're just gonna use the print or printf. So here, if I just say print and I give it a string, it just prints it out to the screen. Or if I'm running it as a program and I have it redirected to a file, it prints it out to wherever standard output's gonna be. I can also explicitly say print to standard out, or if I wanted to print some error message, warning message, I can say print to standard error. And if I've opened up a file or opened up a pipe to some command, then what I would do is I would give it the name of the file handle that I'm printing to. The same that works with print or printf. And notice that if you're gonna put parentheses around your arguments, which are optional for most Perl functions, you put the file handle outside of those parentheses. Now, if I'm reading from input, if I'm reading from standard input, then I have two less than and greater than, nothing in between. And that by default means read one line from standard input. And if I put the file handle in between the two less than greater than, then that means read one line from that file handle. The system read is a little bit different. It takes actual arguments inside the parentheses. There's a, let's see. Okay, here's the function open. So if I look at this, if you go through the manual for the open function, it will give you a whole bunch of different examples and walk you through how you can open file for read, for write, for appending. And let's say you want to be able to open it to read and then write to it, to do more than one thing bidirectional. There's a whole bunch of different ways to do that. So I would recommend going through that if you're going to be doing a lot of file I/O. In addition to working with reading from opening files to read or write, you can either read from commands or write to commands. So in this case here, I'm going to run a command called bin ps. Okay, so if I go over here and say ps au, that's going to print out all the different processes that are running on the system at the time. So what I can do is I can open up a pipe. So what it will do is it'll spawn off, it'll fork off a command to run this ps command, and then I can just read that command line by line. And what I've done is I assign that to this file handle here, ps. So if I want to go through and just look at those that are not owned by root or Apache, for example, then what I can do is I can call this function here, grep, which we'll get to, hopefully we'll have time to get to grep. So what this does is it just searches for a pattern, and as long as that pattern does not match, then it's going to store that into this variable here, lines. So what this does is this opens up a command, and then it just allows me to read them in, store them into this variable here. So each element of this variable, of this list here, is going to be one line of output from the ps command, as long as it doesn't match this pattern. And then I can just print them out. So if I just want to print out the first 10 lines so if I do this, run this. So basically what this does is notice before when I did this, there's a whole bunch of things that are owned by root. Root is the super user. But if I just want to ignore those, then I just want to look at, okay, what's going on? Okay, here's some that are owned by me. Here's some that are owned by some other users, some system programs and so forth. So this just basically takes in the first, well, 0 to 10, so that's 11 lines, and prints those out. Okay, so by using the open command and putting the vertical bar after the name of the command, then what I'm doing is I'm reading from that. That's an input that I read from. So by doing the less than, and then I have the file handle, and then greater than, that means read from that file handle. And then I just bring all of that in, and I pipe, or I filter it through this function here, correct? And you can do, like, if you have special file encodings, there's ways that you can do. If I want to open up a file and write to it using a specific type of encoding, then I have to use this format here. And again, I would look at the open command here. That gets into the how to do the encodings, because I've run into that in a few cases where I have to do processing on some file, and if I don't have the encodings lined up, it complains. So I had to research how to do that, and basically I just read this manual page here to figure out how to do that. Working with binary files, we don't have time to go over that, but there's manuals for system open, system read, system write. And there's also a tutorial, there's a function called pack, where basically if I've written a program in C and I have a C structure and I dump those into a binary file, and then I want to read them into a Perl file, this walks you through how to convert, like how to line up the bytes on the correct boundary, how to have them the correct size and so forth, how to do the byte ordering if it needs to do some translation and so forth. So that's very useful if you're working with any kind of binary data that's written by a C or C++ program. All right, so now I showed you earlier how you can open up this command and read from it, and then I called the grep command, or grep function, and I gave it a pattern. So what is the pattern? That's a regular expression, and you may have encountered these with other languages, or you may have used the grep command on the command line or something like that. But regular expression is just a way to formally put together a pattern that you need to match. Unix has had regular expressions for decades, but Perl added some extra power to these regular expressions. So a lot of times in other languages, you may see something that says, "Oh, this you call this, and this has Perl regular expressions." And so that follows the rules that Perl has added to the old style regular expressions. So here's some examples. If I just have letters in between the search here, what that means is only match if this is somewhere within this string here. So what this does here, if I have a variable and this has some string in it, I'm going to test this against this pattern. And so what this does in Perl is it says if I have equal to tilde, that says, okay, connect this pattern to this variable and test to see if it matches. If I have exclamation tilde, that says test to see if it doesn't match. It's just the opposite. And so if it's just letters, then all it's going to do is it's going to scan through that string and look for those specific literal letters. So I can match a number of different strings with that. I can put some special symbols in there. For example, the up caret, that means that anchors it to the beginning of the string, at the beginning of the line. So it says, okay, at the beginning of this string here, you have this pattern here. And the square bracket is a character class that says you can either have A, B, C, or K. You can only have, but it only matches one letter. So I can match ASH, BSH, CSH, or KSH. But I couldn't match the string bash because the B and the A are two separate letters. So this would only match one letter. So if I wanted to, I could put a symbol here to indicate I want, one or more. But in this case, I'm only matching one character. Now here, I'm using dot and star. Star means whatever you had before, you either match 0 or infinitely many, 0 or more. And then the dot means match any character. Now, if I want to match only the symbol, the period symbol, I have to put a backslash in front of it. So the backslash is they call it an escape. That means treat the next character as literal. So you have all these special characters within the regular expressions, and then the backslash says, okay, forget the normal rules for this next symbol. We only want to match that symbol itself. So this expression here says, okay, you're going to have multiple characters or 0 or more characters. Then you're going to have a dot, and then you're going to have one letter, which is either a C or an H. Okay, so if you have some programs written in C, and you have xyz.c, xyz.h, so this pattern here would match that. And when I say this, not matching, what I want to do is, let's say I'm going through all of the files within a directory. I want to say all the ones that are not .c or .h. That's what this test would be here. Now, there's another, a few other things that you can do with regular expressions. One thing is you can do a substitution. And this would take the form of, you could say substitute, and you have one pattern, and then you replace it with another pattern. Now here, instead of having the slash, which is standard, since part of my string here, the pattern that I'm going to replace it with, has slashes, what I do is I use a trick in Perl where instead of putting the slash, I just give it a different character. And there's a number of different characters that you can use. Sometimes you can use braces around it and things like that. If you go through the Perl regular expression tutorials at the Perl Doc website, it'll go through all the different ways that you can do, the different characters you can use for this. But basically what this does is it says match at the beginning of the string and substitute at the beginning /usr/bin. So what that would do is whatever this command is, it's going to add /usr/bin in front of the command. And so I'm assuming that this has a slash at the beginning. And then this does transliteration where it'll take all the capital letters and change them to lowercase and things like that. Okay. One of the things that you can do is you can do a pre-compile. So let's say you're taking a pattern and it has some kind of, normally what Perl will do is if I put inside of an expression that some kind of expression that I'm going to do a test against, if I put a variable in there and it does interpolation, it will assume, okay, since it's a variable, I have to recompile it every single time. But if I wanted to, I could pre-compile it so that it doesn't have to do that. That's a little bit esoteric, so I'm not going to get into that. just so you know that there's a way to pre-compile it to speed things up. You can do the match, which you can either have it just the pattern itself, or you can have an M in front of the pattern. The substitute, as we saw, transliteration, which is either TR or Y. And then as you can see, there's a number of different ways where I can specify the patterns, either with slashes or question marks or braces and things like that. Again, I recommend you go through the tutorial for that. It'll give you all kinds of examples on how to do that. So let's see how we could use these regular expressions. There's two functions, split and grep. Split will take a function or a string and you give it a pattern, and what it will do is it's going to split this pattern. It's going to assume this is like a record, and it'll say, okay, my record separator is this pattern here. It's either a colon or a comma, and it will treat each one of these symbols here, either colon or comma, as a separator between fields in the record. And it split will return back a list of every field within this string using these separators. So A would be the first one, F, G, X, and then blank, or empty string, 2, and then 3 space KB. And so each one of those would be items within the list that split returns. Grep is just like the search function that you have in Unix, where you say grep, and then you give it a pattern, and then you search through here. So this pattern here says you have to have a capital A at the very beginning, you have to have a lowercase s at the end, and you have anything in between. So it would match atoms, it wouldn't match this because it doesn't have an S, it would match this, but it would not match this because it's a lowercase. Okay, so here I start with a string. I'm going to split it using the split function, store that into this list here full, and then I'm going to go through and I'm going to filter that full list and pick only the ones that match my pattern. So when I run this first splits the string. It shows it how I've created the full list, and then how I just winnow it down using the grep function. There's a lot of, like I said, read the regular expression tutorial. Let me go over some of the meta characters. There's a lot more. There's the backslash to do the escape, the anchor to the beginning and to the end. The dot matches any one character. Then you can have, if you have a group of things, you can say either match this or that, and you alternate between, you separate the different options with a vertical bar, and you can group those together with the parentheses. Now with the grouping, what happens is you can actually capture certain parts of your pattern and store those and then process those. And then the character class, which we showed, which like any character which is in, you know, A, B, C within that grouping. Quantifiers, if you put a star after part of the pattern that says 0 or more, a plus says 1 or more, question mark means 0 or 1, and then you can get into the actual, you know, specific number. You can limit it, you know, between 2 and 5, for example. The escape sequences, there's \T for tab, \N for new line, or you can put, you know, use specific ASCII characters in there by specifying the octal number for them. -L, if you're doing a substitution that says when you replace it, you're going to make the next letter lowercase. Or \U says make the next one uppercase. So you can like copy some part of your string and say, okay, make the first, you know, capital capitalize the first letter of this word. And then some of the ones that I find very useful are \W that matches any word character, which is either like any letter, number, or underscore. Or \W means the opposite. \S means any space character, so you can have a space, a tab, and so forth. And \D is for a digit, numerical digit, so that's 0 through 9. And then \1, \2, \3. This is actually, these are outdated because they no longer like for you to use the \1, \2, \3. They prefer that you use $1, $2, $3. So what happens is, if I match, like I have a line here, and I said, okay, I'm gonna have some word at the beginning. So word characters means not space, like letters, numbers, and underscores, and then a space, and then some numbers, and then an optional space, an optional, 0 or more spaces, and then some. Here, this last one, I have a question mark, which means 0 or 1. Okay, so this says, in this pattern, I have a word, a number, and then an optional word at the end. It's because I have this question mark. But the parentheses, what happens is I can take, if I match this to the line, then whatever this word is, gets stored in $1. Whatever this number is, gets stored in $2. And this gets stored in $3, and this could be empty if there's no word at the end. So then I could take a name that's last name, comma, first name, and I can reverse it by doing this, by matching this with this. And I can just from experience, I can tell you that there's many people who do not follow this pattern with their names. Many people have multiple words for their last name, or their first name may be multiple words, or they could have junior or senior, or things like that. So this is just a very basic pattern matching. That if you have one word comma another word, it just switches the two. And then this one. Okay, here's a construction where you say, okay, I have a string stored in $n. I'm going to match it to this pattern here, which is one word, another word, and then a third word. And I just want to ignore the second word. So I only care about this one and this one. And so I store, if this matches, then what happens is $1 is the first one that gets returned. $2 is the second one that gets returned. So this is, instead of having to work with $1, $2, and so forth, you can just take that string match and store that into some list of variables here. So you can just pull those out and store them into the variables that you're going to, you're wanting to extract just those parts of the pattern. Yeah, this is I put together a whole bunch of different processes that we used before. This uses the IO file module, which basically it lets you open up a file for reading, and this opens up the etc password file, creates an object, which is a file treated like a file handle, password table, which is open for reading. And then I also run that command ps, and I have all these arguments. And so what I want to do is I want to read the output of that line by line, and this gets open and stored in this file handle here. So one file handle is the file etc password, which just has a list of all the users. It doesn't have actual passwords in it. And then this one has the output of that ps command. And this first loop, what I do is I go through the password table, I split it up. If you look at password. What it has your login name and that what would have been your password, and then has the numbers which represent your user ID, login ID, and so forth. And then it has like your name, and so these are all system things. So then we get down into actual users. So I know that the first one is the login name, and then the fifth one is the actual human name. So what I would do is I look at field 0 and 4. And what I want to do is I want to get the real name for the person, but I don't care about the system accounts. So I only look at the ones where the number, the user ID is greater than 1,000, because everything under 1,000 is system things. We don't care about that. So I only care about the real names of the people. So what I'm doing here is I'm going to store these names into this hash table here, based upon the login name as the key, and then it has the real name. And I use the split to break it apart because it's all put together with colons. Okay, and this one, it reads the PS command, and then it looks to see, okay, the first one is the login name is gonna be the first part of the line. So I'm gonna match the word, the very beginning of the line, anchored to the beginning, and that's going to be stored in the variable login. As long as this exists in this hash table here, if it exists, then I'm going to keep going. Otherwise, I just call next. Next just means skip it, go to the next loop item. And then what I want to do is I want to initialize it to 0 unless it already exists. So if the number of processes were already started, then I'm going to add 1 to it. Or I always add 1 to it, but I have to initialize it to 0 if it doesn't exist yet. So this tests to see, does this exist? If I've encountered this user before, if I haven't, then I have to initialize it to 0. And then after that point, then I just keep adding 1 every time I hit a process that user is running. Okay. And then I just print out a list of all of the users, their names, and the number of times that the number of processes they have running. So this puts together a lot of the different concepts that we've gone through so far. So all of this together, basically, it just says, okay, this user is running 22 processes, I'm running 6, and this other user is running 4. Okay, so you can go through, and a lot of that may be a little confusing, but it does illustrate a lot of the concepts that we've gone through so far. I don't have much time. Let me go over references. References in Perl are another word for pointer. So I can create a reference to a variable that exists. All I do is I put a backslash in front of that variable. So I create a reference to a scalar, a reference to an array, a hash table, or I can even make a reference to a subroutine that I've defined. I can also do an anonymous pointer or anonymous reference. So if I want to create an array, normally I would put the round parentheses around it, but if I put square brackets around a list, what that does is it creates what's called an anonymous array, anonymous list. And so what this does is this is actually a pointer. It's not the list itself, it's just a pointer to this list that gets created. And it's not stored in a named variable. All I have is the reference to it. And then this is how I do it with a hash table. I use the curly braces. And then for a subroutine, I can do sub and then like this. Whenever I want to dereference what I'm working with, if I'm working with the scalar, I have to put a dollar in front of the reference. If I'm working with an array, I put the at symbol in front of the reference. And so the formal way to do this is you put the reference inside of curly braces and then you put the symbol outside of it. So dollar sign for scalar, at symbol for array or list, and then percent sign for hash table, and then ampersand for subroutine. That is if you want to be very careful with your syntax. I can also leave off the braces, so instead of having the pointer inside of curly braces, I can just leave it off. And so that creates a combination. Then I have like at sign, dollar, percent dollar, things like that. That can get a little confusing to read. But normally what you're going to be doing is if you're working with lists or hash tables, you just want to get to one specific item within the list or the hash table. And so what you can do is, in this case here, like you have, I want to get to item 3. So the very pedantic way to do that is to put that in to the curly braces or like that. Or I can use arrows. The arrow is a much easier way to work with. So let's say I have an array reference, and then I just want to get to the third item. Then I just use an arrow, and then the index that I'm going to be looking at. Same thing with the hash table. I just use the arrow like that. Now you have to be careful because if you forget to put the arrow, then it's going to think, oh, okay, I have a hash table by this name. Again, that's why I recommend don't reuse names and also turn on strict, because if I forgot to put the arrow in there and I didn't, and I had turned strict on, it would give me an error. It'll say, oh, you're trying to reference a different variable that doesn't exist. So therefore, it's not going to let me do that. The same thing with subroutine. I can make a pointer to some subroutine and I can call it this way. So putting all that together, if I want to have a multi-dimensional array, basically what I said before is since lists are one-dimensional, then I can create a multi-dimensional array by having these anonymous arrays within them. Or in other words, table is going to be, it's going to be a one-dimensional array, but each element is going to be a pointer to another list. So if I want to get to item 1 and 2, so that would be index 0 here, index 1 here. Okay, so if I want to get to 1, 2, that would be index 1 and then 0, 1, 2. So that would be the number -9 in that case. So you can get a lot more complicated working with the data structures. And I highly recommend going through this data structures tutorial. And this will show you how to do arrays of arrays, arrays of hashes, hashes of arrays, and etc. Always turn on use strict so that if you forget to do the arrows or something like that, that it's going to catch that error and it'll print out the error message and you can fix that. But if you go through this, it goes through in many different examples how to do all these different types of structures. There are more slides from previous courses that we had. If we go back many years, there's a PDF here, and this has a lot of the slides that I didn't have time to get through today. You can go through that, and there's also an intermediate scripting That includes Python and Bash as well as Perl. So we have slides for those as well. And anytime that you have any kind of issue with Perl, you can always send us email and they'll let me know and I can help you with that. So, does anybody have any questions? I know we went through a lot, yeah.
So aside from readability, is there any difference between saying until or while and having not?
Yeah, it's mainly readability. It's just
More ways to do
you can
things,
say while not, or you can say until.
or I could say while and exclamation point instead of actual NOT, right? Okay.
Right.
Okay, that's cool.
Yeah, and it's a very, it has a lot of features and every time, like when I go to write the put together the slides and everything, I discover something new and so,
Yeah.
but honestly, I do everything in Python these days, so but we have some legacy code that's in Perl, so you know. But a lot of people use Perl for bioinformatics, things like that. So it's very useful for those things. All right, thank you.